Hello everyone. This lesson we're going to talk about open delta calculations. If you remember before we talking about open delta, we said for 3 single-phase transformer, we build a 3-phase transformer bank. There are some advantages is one of the transformer break down, we can still use 2 of the transformer to supply 3-phase load. This is the case with open delta. So I have a drawing here. I have 3 transformers. I draw the 2 with red line, which we're gonna keep that 2. The one with the green line for the connection, if that's the one break down, we're gonna taking that out for the service. We still have 2 transformers connect on there. That's open delta connection. So to explain that, I put a 3-phase balanced load at the bottom for the secondary of the transformer. We can calculate with all 3 transformers in there how many load we can supply, and with 1 transformer removed from service, we only have 2 transformers connecting open delta condition, how many load we can supply. So my supply is 3-phase, 3-wire, 600 volt. We don't care too much about that. Because our load is connected on the secondary, we're more focused on the secondary. The load requires 3-phase, 3-wire, 240 volt. That's our secondary voltage. Each transformer is rated for 6 kVA. If under normal delta to delta 3-phase transformer bank, we know the maximum kVA can be supplied by 3 transformers, will be 3 times 6 kVA. We have a total 18 kVA for the load. That's the normal condition. So on the secondary side, the line current is going to be the total kVA divided by root 3 times the line voltage. I did the calculation, 18 kVA, root 3, 240 volts. The line current is going to be 43.3 amps. The phase current, we use the phase current formula. We calculate the phase current is going to be 25 amps. That's under normal condition. And we try to figure out each transformer, the secondary winding current rating. So for individual transformer, that's what you learned in second year. 6 kVA is the rating, 240 volt is the rating. We can find out the current rating for the transformer winding will be 25 amp. And you can see here, the current rating for the winding will be the same as the phase current for this 3-phase transformer bank. So these 2 exactly the same because we have a single coil or single winding transformer. The phase current will be the coil current or the winding current. Now let's look at if we remove one of the transformer. So the green line is not going to be existing anymore. We don't have them. We only have 2 transformer connection. These 2 transformers, still we connect the primary side connect on line A, line B, line C. The secondary side still connect on line A, line B, line C. But here it's slightly changed. For line A, we only have a 1 winding from a phase A transformer connect on there. For line C, the same thing happened. We only have a 1 wire from transformer B, the winding connect onto. Line B, we still have 2 line connect on there, but for line A and the line C, we only have a 1 line connect on there. That's the big difference. Still, we have a 3 line, we can supply 3-phase power. So let's look at it. Now the line A current. The line A current only going to be supplied by 1 of the transformer winding, 1 of the coil down here. Line C current, at the same time, it's only going to supply by 1 of the transformer winding and 1 of the transformer phase. So line A current and the line C current now become equal to the winding current or the phase current of the transformer. We calculated before the winding current, the phase current, going to be 25 amp. So we have 25 amp here. Because now we know these two lines can only supply 25 amps. For that, that's going to be our line current. Then we can figure out what's the maximum kVA of the load could be supplied by this open delta transformer bank. I use the formula, calculate maximum load kVA, √3 times E line times I line. Put the number down there, √3, 240 volt. That's our line voltage, 25 amp. That's what we just calculate, or we find out. That's going to be our new line current in open delta connection. The total kVA of the load becomes 10.39 kVA. So that's the maximum kVA of the load could be supplied by this open delta connection. This 10.39 kVA is going to equal to √3 times 6 kVA. Each transformer was rated for 6 kVA. It's also going to be equal to 18 kVA divided by √3. So I put here the simplified calculation. If you want to find out what's the maximum low kVA can be supplied by the open delta connection. Each transformer is rated for 6 kVA, so the maximum load could be equal to √3 times each transformer's kVA rating, or could be, if I have a 3, I have 18 kVA divided by √3, that will give us the same maximum kVA rating for this open delta transformer bank. Also, for this 10.39 kVA divided by the original 18 kVA times 100%, going to give us 57.7%. So open delta can only supply 57.7% of the original three-phase load. So if we're ever using open delta, in case one of the transformer breaks down, you have to reduce the load to 57.7% of the original load you put on there. Here is the open delta calculation. If you have any question, you can connect us online or send us emails.